This lesson is about population dynamics. And let's start by talking about distribution of a population. And so one of the ways that they can distribute is in a clumped population. And these two pictures, I should say, come from a WordPress blog by Mark Abrams. And he's got some fantastic photos from Africa and elsewhere. So if you like these photos, I definitely check out Mark Abrams' WordPress blog and other sites. But this is a clumped. So notice these zebras here; they're clumped, and the zebras are clumped. And look at how those lines make it so it's hard to tell one from the other. And so this is one kind of distribution, is clumped, and often prey species will be clumped, and we'll talk in the next video about the advantageous behavior that is. Versus a predator species will often be evenly spread over an area. So you'd have just one or two in a large area, and they're spread out. And if you think about that, these animals here, they're not really competing for food. There's plenty of food. It's all around them. So they're clumped together. Whereas these animals are competing for food, and they need a lot of food to support their needs. And so they have to be evenly spread out to get enough food resources. And so depending on if you're a prey or a predator, that's going to determine whether you are going to be clumped together or evenly spread out. And then the amount of resources that you need and what kind of resources that you need are going to determine whether you are spread out. So if we're looking at a large area and in our population, we might see that the predator species or the prey species find themselves in clumps here around water holes and food sources and things like that. And these clumps might be moving around, but still in clumps. And then the predator species might be only 3 of them in the same area, and they're spread out to get at the food resources that move around. And if you think back to the previous discussions about energy, there have to be a lot more of the prey species to support the predator species, as so much of the energy is lost as it moves up the food chain. But what I want to talk to you here about is population density. And the population density is the number of individuals per area. So it's going to be in meters squared for something small, or like a mice, or it's going to be number of individuals per kilometer squared, say for something like zebras and large predators here. And we're just looking at the number in an area in a square kilometer, square meter, and that number then, the density is those number of individuals divided by the area. And you can see why it would be important then to do things like mark and recapture or tag them to know the individuals, because these boundaries here that they live in are not hard and fast, and so some individuals are going to leave those and some different ones are going to come in. And so we're looking at an average over a set of time. Now let's talk about what might change these. And there's really 4 rates that we talk about. And so we have the birth rate and the death rate. And these influence survival. And then we have the emigration and immigration. And these often get confused. And these really relate to whether they should stay or whether they should go. And so in our population up here, if we have a zebra moving out into a new location, it has emigrated from here and immigrated into a new location here. So you emigrate from a place and you immigrate into a place. And why might they be doing that? So let's think about why they might be doing that. Well, they are going to emigrate from a place if they are low on food and they're running out of food in that location, or they are not finding a mate. They're going to go to somewhere else where they can find a mate. Or there are too many predators, and so they have to leave to get away from the predators. And they're going to immigrate into a place for just the opposite, to find food, to find a mate, to find shelter, to find water, etc. So the same reasons humans emigrate and immigrate: to find jobs, to find work, to find a livelihood, and so these are the four things that will affect the population density. The population density will go up or go down as more individuals, as the rate of individuals are born. So birth rate isn't just how fast they're born, but then how many are surviving. So we don't really care how many are born, it's also how many survive long enough to have offspring of their own. And the death rate then is the rate at which they're dying, of course. And this is certainly influenced by things like food and shelter and water and predators. And so these are going to be highly variable depending on the conditions around them. And in response to those conditions, they might choose to emigrate or immigrate. Now, I don't want you to confuse this with dispersal and with migration. So let's talk about dispersal or spreading, which is different than distribution. Distribution was whether they were clumped or not, and how they were spread out in a location in a certain with a certain population density. Whereas dispersal is, sometimes we could use the word range. And so let's look at this cardinal here. In the United States, so let's draw a very rough map of the United States. In the United States, the cardinal used to spend its winters with a dispersal like this, or a range, could use that word, and then in the summers it would expand northward. And so its dispersal and its spread was during the summer months, the whole continental U.S., and during the winter months, it went south. Well, this bird has modified its behavior and shifted its dispersal or its spreading, and it is spread so that now in the summer and in the winter it stays in the northern climates, and those some stay in the southern climates. And so it has spread its dispersal into a bigger range. And this happened because people started setting out bird feeders, and the cardinals adapted and learned that there was food available in the wintertime, and it was frankly easier for them to stay in the northern climates when the snow came and get food from the bird feeder than it was to spend all that energy flying south for the wintertime. And so they changed their range, and their dispersal spread over a larger area of the United States. Now let's talk about how this differs from migration. This migration, let me get a little more space here. Migration is a seasonal movement. So many birds move south for the wintertime. The cardinal used to do that. And it's often for climate or weather, like cold winter, but it's also for other seasonal changes. So the wildebeest here are migrating in Africa, not for winter and summer, but for the dry season and the rainy season, and they are following the water. And so migration is a seasonal change, but they're not spreading their habitat or their range. They start in a location, they move to a new location, and then when the seasons change back, they go back to their original location from their secondary location. And so their range or the dispersal would be this here. Just it would be seasonal. So the hawks do this. So in Minnesota, we have, so let's do another crude map. Here's Lake Superior. Here's the arrowhead of Minnesota. Here's Wisconsin. Here's Minnesota. And the hawks, they spend summers up in this region up here. Now they don't like to fly across Lake Superior. And so they migrate down along the coast through the town of Duluth along an area called Hawk Ridge, which is a bluff that has good thermals and updrafts, and so the hawks can soar. And they get through this bottleneck here, and then they spread out all throughout the lower part of the continent for their summer, or excuse me, for their wintering. And then back in the summer, they come back and they don't want to go over the Great Lakes, and so they are forced to go back through Hawk Ridge, and then they spread out up into Canada and wherever else they want to go north of the Great Lakes. So that's the difference between migration and distribution and dispersal.
If you say that you are mine, I'll be here till the end of time. So you got to let